Well, we're just about into August now, and with that in mind, you're going to be seeing me a little bit more here on Tropical Tracker. Thankfully, the Atlantic Basin not giving us too much to think about this time of year quite yet. If we shift gears over to the East Pacific, though, and actually the Central Pacific at this point, Hurricane Dora, located to the south of the Big Island of Hawaii, has had a very long life cycle, tracing its origins all the way back to the Atlantic Basin and even over Africa, where it was designated originally as Invest 95L, failing to develop in that part of the world, but eventually doing so upon crossing over into the East Pacific. And now you see that symmetric, almost donut-like appearance, a Category 4 hurricane, and one that has generated twice the accumulated cyclone energy of the entire Atlantic season so far, giving you an idea for just how long it's lasted. With that in mind, though, it's a relatively small storm in an environment of pretty dry mid-level air, and it's taken on this so-called annular structure, as we kind of a buzzword we use in the tropical meteorology space, to essentially shield itself from that otherwise hostile thermodynamic environment. And with that, it's expected to kind of stay well insulated and keep its intensity for the better part of the next few days, really for the rest of the week, before eventually crossing the international date line, officially crossing into the West Pacific in the next 5 to 7 days, and eventually weakening into a tropical storm and ultimately decaying into a post-tropical low-pressure system. And this was the evolution of Dora a few days ago here as it intensified rapidly into a Category 4 hurricane. Oftentimes, it's just that right burst of convection at the right time, in the right place, and you kind of see this take off and that eye really form very quickly in a matter of just 6 to 12 hours or so, where you really start to see that clear out and become much more symmetric as it eventually entered that slightly drier environment. So not too much in terms of favorable environments out there in the Atlantic Ocean, but once these waves cross over into the Pacific and tap into some of that oceanic fuel and that warm water out there, then it's been a bit of smoother sailing for these waves in that part of the world. But over in the Atlantic, we are still a little bit above average here in terms of our accumulated cyclone energy. This is a useful plot from cyclonicwx.com made by a former colleague of mine at Florida State University, Alex Borham. Our average amount of ACE units is about 11 to 12 or so year to date, and this is ranking for 2023 15th out of a compilation of the past 73 years of data. So nothing overly shocking necessarily, but just hanging a little bit above our average, which we've been in since June. However, this is the time of year where we'll start to see business, climatologically speaking, pick up a little bit. This black curve showing the average ACE over the 73-year time span really starts to see more of that exponential almost increase as we move through the rest of August and into September, our peak of the hurricane season, climatologically speaking. However, right now, not really too much going on. Dry air over the Gulf of Mexico and over the western Atlantic Ocean in the wake of the severe weather that we had throughout the mid-Atlantic yesterday. And just a couple of waves bringing some unsettled weather to portions of the eastern Caribbean and out into the main development region of the Atlantic. I'm going to go ahead and zoom in on this particular wave off the northeast coast of South America, not necessarily because of significant development potential, but actually because of a research mission that was flown over this system in the overnight hours here. So this is called the Magpie mission, sponsored by the Office of Naval Research, and it was a mission where they basically flew the NOAA G4 Gulfstream 4 aircraft in this kind of lawnmower-like pattern just to the north of this wave to try to sample what was going on in the lower atmosphere, specifically the atmospheric boundary layer, to see some of the water vapor and temperature structure in the low levels of the atmosphere. And I encourage you to check out Marissa Ferger's fantastic piece about the Hurricane Hunter aircraft themselves that aired a few years ago back on Weatherworld and is available on a YouTube playlist here. So you tend to see patterns like this even when it comes to active storms in this G4 upper level reconnaissance kind of framework here. Maybe you see something like this too from Hurricane Teddy in 2020, where maybe you have this sort of star-shaped pattern of these long arcs that tend to operate at relatively far distances from the hurricane center. You see the eye of Teddy right here from 2020, a powerful Category 4 hurricane. They tend to avoid the centers of these, especially strong storms in this case, because of dangers associated with turbulence and wave activity in the upper atmosphere. But you do get very valuable information from these upper level planes, namely kind of detailed vertical structure about the winds and the thermodynamic structure of the atmosphere. This is a profile from a dropson, basically a reverse weather balloon that descends through the atmosphere on its way down from the plane to the ocean surface, and these are just plots of temperature and dew point as we descend down the path that this dropson took. And you see in this particular case from last night's mission, a big spread between the red and the green here, between the temperature and the dew point. In other words, there's a lot of dry air in the immediate environment of this particular wave, preventing significant development. But let's look at another case with the NOAA P-3 aircraft, or in this case, actually, it's an Air Force low-level reconnaissance aircraft that basically is designed to fly right into the centers of these storms. And you tend to see these sort of alpha butterfly-like patterns that essentially ride the tailwind in order to conserve fuel and make multiple passes through the centers of these storms in a given mission here. You see this wind shift in the barbs that are kind of oriented in opposite directions, meant to indicate the centers of these storms. And with this, you can kind of track how the wind field evolves. You see this asymmetry with stronger winds marked by the purples on the right compared to what you're seeing over on the west side of the storm, for example. The pressures decreasing just a little bit from about 942 to 937 millibars, for example. And if you track this over the length of one of these missions, you can kind of see little subtleties in the details of, for example, the minimum pressure is going down, given by this red line over time. The maximum winds at the flight level, about 10,000 feet above the surface, is going up. You see the increase in the kind of peak of these blue lines. You see little spikes in the temperature. These little details that we can use and you can use following live on tropicaltidbits.com to be able to track this information in real time should we eventually see a little bit more hurricane activity peak as we get into the climatological peak of the hurricane season. More after this.